Hello everyone, my name is VARSHA YADAV, Assistant Professor in School of Applied Sciences in Shri Venkateshwara University, and my topic of presentation is role of natural dye in photovoltaic performance of dye synthesized solar cell application. These are the outlines of my work. First of all, motivation, next introduction, then experimental details, and resultant discussion, and after this summary and conclusion about my work. This is our need. Energy consumption is up to 1.11 into 10 to the power 14 in 1 year, and energy supply from the solar energy is 1 hour is up to 1.78 into 10 to the power 14. According to this ratio, we can easily say that solar energy is the most efficient energy and free of cost ratio, because we need this ratio, and solar energy supplies this ratio. This is the very convenient to very convenient to say कि solar energy is the very useful sources for our requirement. According to energy consumption areas, solar energy is a safer, environment-friendly resources to solve energy crisis and environmental problems. There are many resources, alternative resources are available, but according to all sources, solar energy is the best source of an of energy, renewable energy sources. Solar energy is a commercially available and reliable technology with a significant potential for long-term growth in nearly all the world regions. That's why solar energy is the most stable energy sources, and it's a free of cost sources. And this is the solar cell as a branch of photovoltaic device which is easily convert the solar energy into electrical energy. And this is the three generations. They are classified in three generation, and the synthesized solar cell is the third generation solar cell, which is firstly invented in 1991 by the All-Gregan and Mikkel Gerson, and the principle of DSSC is very similar to photosynthesis process in plants, and it's comprised in four components, mainly semiconductor electrode, dye synthesizer, counter electron, and next one is electrolyte. And DSSC utilize the dye molecules to harvest the sunlight. And the best properties of DSSC is to absorb more light under cloudy condition than silicon-based photovoltaic cell. And it works in indoor lights. Also, it's under artificial lights. And these are the structure and component of DSSC. First one is conducting glass substrate, and it should be high conductivity and transparent. Next one is working electrode, which may be oxide, like titanium dioxide, zinc oxide, and it should be high surface area conductivity and stability. And next one is photosynthesizer. It's a dye. It can be synthetic dye, organic dye, natural dye, many more. And it should be wide range absorption and highly stability. And next one is electrolyte. And it could be stable redox material, high good stability and good solvent and high interaction quality with the dye material. And next one is counter electrode, which may be a metal or non-metal. It should be high surface area, catalytic activity and stability. And the solidification properties should be high solubility of redox stability and conductivity. And this is the working principle of DSSC. Firstly, dye molecule absorb photons from the sunlight and excited the electron. Then transfer of electron from to TiO2 layer from the dye molecules, and after that degeneration process will happen on by degeneration process happen of oxide dye using a hole carrying electrode with the electrolyte. Then electron transport from the TiO2 layer to external load. Then again regeneration process are happen at counter electrode place between electrolyte and counter. And the experimental details. This is a novel dye material which is used in my work. It is natural dye, which is made by harda fruit. Harda fruit is the oldest vegetable of Rajasthan, and this is the photo of solution of natural dye, and this is the DSSC device which is made by natural dye, and this is the also a natural dye solution photograph, and the composition is dye solution is 0.33 mg per ml, and dissolving in absolute ethanol, and this is the extraction process of natural dye from the hata fruit, and in this process we use the server small process to extract dye powder from the fruit. And firstly we dry the fruit and then boil this solution in distilled water and separate this by using filtration, then sonicate, and after bath evaporation and some other process we get the dry powder of other fruit dye. This is the process of DSSC fabrication. First we use the cleaning of FTO substrate by using DI water and ethanol and isopropanol. Then after that we apply the compact layer of TiCl4 CI4 solution to interact TiO2 paste with the conducting glass substrate, and after that we applied the TiO2 paste layer by using Dr. Blade method, and then annealing this FTO substrate at 470 degree for 40 minutes, and after that put this photoanode portion in a dye synthesizer for 24 hours in a dark. On the other hand, we take one more FTO to deposit the platinum layer with the help of Dr. Blade method, and then an annealing process take place at 500 degree for 30 minutes. After completion of photoanode and counter electrode, we merge for both the electrode and fill electrolyte between the both electrode, and assemble the DSSC device. Then result of my work. Firstly, absorption is the key feature of dye molecule dye material we use in DSSC, and firstly dye solution of other fruit shows the absorption properties, which is the very good and successful properties of material to use in solar cell, and corresponding it show the band gap is 3.9 eV electron volt, which is find out by the top plot. And next one is photoluminescence spectroscopy, which is gives the emission spectrum of natural dye. And we know that the photoluminescence properties is equally important in selecting the appropriate photosynthesizer material for DSSC. The steady state photoluminescence spectrum natural dye is shows in figure, which is corresponding to absorption peak in UV visible spectroscopy. The PL spectrum shows an intense and broad emission band from 300 to 420 nanometer, with a significant weak emission band within 660 to 800 nanometer range. The first emission peak can be attributed to the band-to-band transition, whereas the second band observed at longer wavelength, which is in visible and near infrared range, is linked to the decolization of electron in hydrocarbons that helps to harvest the sunlight efficiently and improve the performance of material. And next one in FTI spectrum of natural dye. FTI spectrum natural dye is recording in region of 4,000 to 500 centimeter region, and all the bands are present in FTI spectrum indicate that the vibration observed at 800 3 and 882 position assigned to amine group, and is the function amine group is the functional or derivative of azure and orthoconium compound, and our natural dye belongs to the orthoconium compound group. And next one is the gas chromatography mass spectroscopy characterization of natural dye. This is the graph of GCMS of natural dye, and this is the table of a compound identified in our dye material, and compared to other dye material, which is the same compound element are found because of orthogonal compound. Here we say that this is the compound available in our dye, which is belongs to the orthogonal compound, and this is the identify the new compound structure for new material we assigned. This is the photovoltaic performance of natural dye. This is the JV curve of DSSC under the 1.5 AMG is illumination condition. We can easily say that the our natural dye is successfully used in solar cell application, and which we have successfully fabricated DSSC device, and also we get the efficient result, and photovoltaic parameters are listed in table. This is represented in table, and this table also includes the photovoltaic performance for the other recently development natural dye based DSSC. Natural dye based DSSC effort significantly higher VOC is up to 0.60 volt, and much better current density is up to 8.10 milliamperes per centimeter square. Fill factor we get up to 55 percent, and the for main parameter is power conversion efficiency is up to 2.7% in this work we get with the natural dye, which is very good as compared to the other natural dye as blackberry, pomegranate, red Spanish, and mangosteen peel. We can easily say that our get the best result by using the natural dye material. And conclusion is that natural dye DSSC affords significantly high photovoltaic parameters, and we get a significant result, power conversion efficiency up to 0.7% compared to other natural dye, which is easily available in the review, and the optical band gap was determined using the top load and found it to up to 3.9 eV electron volt for natural dye, and function group observed in FTIR spectrum revealed the presence of carbonyl and hydroxyl group of substance, and GCMS analysis shows the presence of some chemical ratio in dye solution as FTIR. All the properties of natural dye were extensively successfully investigated in this present report, and the novelty of this work is that the natural dye we extract from the fruit, which is I have reported the first time in DSSC application, and successfully get the all the photovoltaic parameter in the solar cell application. And according to this, it's a cost effective and near to eco-friendly environment, near to eco-friendly environment, which is the best solution for in solar cell application. And thank you so much for listening me.